After studying about the electric field intensity, now let's discuss some of the basic numericals on it. Okay. A pendulum bob of mass 80 mg carrying a charge of 2 into 10 raised to the power minus 8 coulomb, which is at rest and at uniform electric field of 2 into 10 raised to the power 4 voltmeter. Find the tension in the thread of the pendulum and angle it makes with the vertical. Now, before going to the numericals, just revise first what we have already derived, that is the electric field intensity along the axial line, along the equatorial line at any point, the uniform 2D electric field and so on. Now, let's start with the first numerical. In this numerical, you can see that we are talking about the pendulum bob. Okay, now this pendulum bob has a mass and mass is given to you, that is 80 mg. Similarly, you can see from the question that there is a charge also associated with it and the charge is given to you 2 into 10 raised to the power minus 8 coulomb. Likewise, the electric field intensity which is acting upon this pendulum is given to you, that is 2 into 10 raised to power 4 voltmeter. So these all the values are given to you and it is also given to you, that is very clearly, and I am specially emphasizing on it because that's a very important point, which is the pendulum bob is at rest. Okay, that means that we are talking about that pendulum bob is at equilibrium position. Now let's start with the diagram first. This is a support. Okay, I am talking about the support from where the pendulum bob is free to rotate. If the pendulum bob is free to rotate, then this must be the position of the bob. If you suspend a string, then string has a tendency to be in a vertical position. So this is the position of a pendulum bob. But in this example, you have to find the tension in the string and you also have to find the angle which the pendulum bob is making with that of the vertical. That means the position of the pendulum bob is displaced. Now in this condition, your pendulum bob has changed its position to this. Okay, this is making an angle with that of the vertical, let's say theta. So this is the theta angle which this pendulum bob is making with the vertical axis. And from the vertical axis, I mean y axis. Now, you have to work on all of the forces that are acting on this pendulum bob. So what are the various forces? Now let's discuss one by one. First force is the tension. The tension which is occurring on the string of the pendulum bob. There is a force. Tension is also a kind of force which is acting on the string. Due to this tension, the bob is connected with that of the string. So this tension is represented as capital T and the direction of the tension is towards the support. Okay. Now, if any body of certain weight, if that body is allowed to fall from a particular height, then the body has a tendency to fall towards the center of the earth. Why is it so? Due to the force of gravity. This means that if this bob is freely suspended at a particular position, then there is a force that acts upon this bob and this force is called the force of gravity. This force of gravity pulls the bob towards the earth. And what is the formula for this force of gravity? It is given by m into g. M is the mass of the bob and g is the gravity constant. Similarly, you can see the position of bob. This is the position of the bob. If any body is placed at a particular angle, that means that we have to require some force to hold this body in a particular position, and that force is represented as capital F. This is the force that is drawing the bob in order to be at an angle theta with that of the vertical axis. So it requires a force. And what is the formula for this force? We have already calculated, that is Q into capital E. Capital is the electric field intensity and Q is the charge which is occurring on the bob. Now, these are the forces that we have talked about, but you can see that the tension, this T, is acted upon at a particular angle. So we have to resolve the tension into Y component and the X component. So now let's work upon the resolving of the tension. First, let's check the angle that T is making with the vertical axis. Now, this T is making an angle theta with that of the vertical axis. That means this vertical axis acts as a x-axis for capital T. Why? Because the angle between them is theta. Okay, now from the diagram you can see that this is T, this is theta. So the x-axis, this will be the x-axis of T. It becomes T of cos theta. Similarly, if you resolve T into its vertical component, then in that condition the angle between horizontal and vertical component 90 degree, and this vertical component is given by T of sine theta. So this is how the T is resolved, that is the tension is resolved. Now we have to look out and check all the vertical component and all the horizontal component. There is one important concept that we need to discuss. The concept is that the bob is at rest, that is the bob is at equilibrium. Now if the body is at equilibrium, it is not moving. Like for example, this is a pen. It is not moving. That means the net force on this pen is 0. Okay. If I apply a force, then that means the pen start moving because I am pushing the pen in this direction. So in this condition, there must be some force acting upon this pen. Similarly, if I am telling you that the bob is at rest, it is not moving. So the net force acting on the bob is 0. That means if I am talking about vertical axis, then all the total force which is acted upon in one direction is equal to the total force acting upon in another direction. The two forces are cancelling each other. So we can write from the vertical component that T cos theta and mg both are balancing each other, or you can say both are cancelling each other because both are equal and in opposite direction. So from the diagram we can write that T cos theta is equals to mg. This becomes equation number 1. Similarly, if we have to look into the horizontal axis, so here also the same concept works. The T sin theta and QE both are in the opposite direction, but both are equal because they are cancelling each other. So in that condition, T sin theta is equals to Q into E. This becomes equation 2. Now, just divide 2 by 1. If you divide 2 by 1, so it becomes tan of theta because T cancel it out. Sin theta upon cos theta is the tan theta. QE upon mg. Now all the values are given to you. Okay. Q is 2 into 10 minus 8. So put the value here, 2 into 10 raised to power minus 8. Similarly, E is also given to you and put the value 2 into 10 raised to power 4 upon m. This is mass. It is 80 mg. For a particular unit conversion, you have to convert mg into kilogram. So 80 into 10 to the minus 6 kilograms. So put the value directly, that is 80 into 10 raised to the power minus 6. What is G? G is a gravitational constant and this value is 9.8 meter per second square. So we have to put the value directly, that is 9.8. Now solve the value, you will get your answer and your answer is 0.5102. So this is tan of theta. Now you have to find theta. That is theta is equals to tan inverse 0.5102. And what will be the value on simplification? You will get 27 degree. That is the angle which this pendulum is making with the vertical is theta, which is 27 degree. We found the second part, but the first part is still missing. That is the tension part. Okay, not that tension. I'm talking about tension, that is capital T. Now, from equation 1 and equation 2, you can take any formula. Okay, any equation 1 or equation 2, in whichever you are comfortable to. Now, let me take equation 1. So, it states that T cos theta is equals to what is written mg. Okay, T you have to find cos theta. Theta is already known to you, that is 27 degree. M, that is 80 into 10 raised to power minus 6 into 9.8. Now this is the first part. Now T is 80 into 10 raised to the power minus 6 into 9.8 upon cos of 27 degrees. Solve this out and you will get your answer. That is 0.008788. So this is attention. Now, if we round it off, then it becomes 8.8 into 10 raised to the power minus 4. So this is all about the first part, that is attention, and this is the second part, that is a theta with the angle makes with the y-axis. Now, moving on to some difficult part. Now, let's start with the second numerical. 2 point charges of 10 raised to the power minus 8 coulomb and minus 10 raised to the power minus 8 coulomb are placed 0.1 meter apart. Calculate the electric field intensity at A, B and point C. Now, as the question states, there is also a diagram attached to it, and the diagram clearly says that there are 2 points, okay? The electric dipole, that is P and Q. So, PQ are the 2 points. At P, the charge given is plus 10 raised to the power minus 8 coulomb, and this is Q1. Similarly, at capital Q, the charge given Q2, which is minus 10 raised to the power minus 8 coulomb. We have to find the electric field intensity at point A. A is the point between P and Q. At point B, B is the point which is placed at certain distance from P and Q. Similarly, we have to find the electric field intensity at point C. And C is the point which is placed here. Now, all the measurements are given to you, that is, P and Q are at a distance 0.1 meter apart. B is at a distance 0.05 meter apart. Similarly, between P and C and Q, the distance is 0.1 meter each. Now, this is the diagram that is already given to you in your question. Now, let's start with it one by one. First, let's start with the point A. So, at point A, if you look here, then this point A is undergoing through the two charges. That is the charge at point P and the charge at point Q. Now, if I talk about this center charge, that is A, so let us first discuss one by one that what is the influence on point A by the charge Q1 and what is the influence at point A by the charge Q2. That is, at point A, we have to find the influence due to first, let's say Q1. Okay, so this is Q1. The polarity is positive in this condition. That means, what is the electric field intensity in this condition? It is outward. At point A, if I am talking about the electric field intensity due to Q1, that is plus 10 raised to the power minus 8. So, it is outward, okay, because the nature is positive. So, let us represent by EP. EP is the electric field intensity by the point P. Similarly, if you have to find at point A the influence created by Q2 charge, what is the polarity of the Q2 charge? Q2 has a negative polarity. That means the electric field is directed towards Q2. It is pulling the point A towards itself. So that means, what is the direction of Q2? The direction of Q2 is this, which is represented by EQ. The electric field intensity at point A is EQ, which is directed towards Q2 because it is negative in nature. So this is how the electric field direction is found. Now let's first find what is EP. What is the formula for EP? The formula for EP is KQ upon R square. Okay, what is K? K is 1 by 4 pi epsilon naught. Q is the charge. It can be 10 raised to a minus 8. It can be 10 raised to a minus 8. Both have the same magnitude. Here we are talking about only magnitude. No sign is required. So it becomes 10 raised to the power minus 8 upon R square. R is the distance between the 2 points. We are talking about the point P with respect to point A. So R becomes PA. This becomes R. So what is R in this condition? Whole PQ is 0.1. So A is at equidistant. So PA becomes 0.05 meter. Now put the value here, that is 0.05. whole square. Solve the whole value, you will get your answer, that is 36,000 Newton per Coulomb. Similarly, we have to work upon EQ also. So what is EQ in this condition? EQ is KQ upon R square. What is K? K is again 1 by 4 pi epsilon naught into Q. Q is 10 raised to the minus 8 upon R square. R is again the distance between A and Q. What is the distance between A and Q? It remains the same, that is 0.05 whole square. All the values are same, so you will get the same answer obviously, that is 36,000 Newton per Coulomb. Now, we have to find the total electric field intensity at point A. Now, it is given by, let's say, EA. EA is the total electric field intensity at point A. You can see EP and EQ, both are heading towards the same direction. That means both the value need to add it up. That is, it becomes EP plus EQ. EP is given to you, EQ is also given to you. Just add the value. You will get your answer, that is 72,000 Newton per Coulomb. So this is all about the point A. Similarly, you have to work upon the point B. Now let's start with it. Now let's talk about the point B. For point B also, we have to analyze it according to Q1 and Q2. Now let's start with point B. Okay, so this is, we have to calculate, and first is the case when we have to calculate it due to Q1. Q1 has a charge positive. That means if I talk about the point B with respect to Q1, then the electric field intensity in this condition is away from point P, because the nature of positive charge draws point B away from the point P. So this is the arrow which is heading towards my left hand side, and this is represented by E of P, that is the electric field intensity created at point P by the charge Q1. Similarly, if you have to see Q2, Q2 has a charge negative which has a tendency to attract the body. So Q is attracting point B towards itself. So what is the electric field intensity? The electric field intensity is towards the charge, that is Q2, and it becomes E of Q. These all are the vector quantity which is represented by like this. Okay, this is also a vector quantity, and this. Now, in this diagram, you can see that EP and EQ are the vector quantity and they are heading opposite in nature. First, let's find what is the value for EP. If we have to find EP, again the formula remains the same. Now I am not going to put 1 by 4 pi epsilon naught. I am going to put the value directly, that is 9 into 10 raised to the power 9. This is the value of K. What is Q? Q is 10 raised to the power minus 8 upon R square. R is the distance between P and B. So, where is P? This is P and this is B. So, what is the distance between B and P? It is given to you, that is 0.05. So, 0.05 is the value. Solve it out, you will get 36,000 Newton per Coulomb. Now again work for EQ. EQ is 9 into 10 raised to the power 9. The charge remains the same, so no need to change. Upon R square. R is the distance between B and Q. This time it becomes Q, the farthest distance. So now let's find the value, that is BQ. This is 0.05. This whole is 0.1. So add the value, you will get 0.15 meter, because 0.1 and 0.05 gives you 0.15 meter. So in this condition, R now becomes 0.15 whole square. Solve the value, you will get 4,000 Newton per Coulomb. But in this diagram at point B, you can see EP and EQ are going in opposite direction. So what is the net force at point B? The net force is EP minus EQ. Similarly, EP is given to you, so on subtracting these two values, you will get 32,000 Newton per Coulomb, or we can say so 3.2 into 10 raised to the power 4 Newton per Coulomb. So this is the electric field intensity calculated at point B. Now let's move on to the next step, that is to find the electric field intensity at point C. Again, at point C, we have to find the electric field intensity due to Q1 and due to Q2. So, at point C, we have to find due to, let's say, first part Q1. Okay, this is Q1 and the electric field intensity as it is positive in nature, so the electric field intensity is away from it. Let's mark it as EP. Similarly, we have to check that what force of the electric field intensity is created by Q2. So in this condition, it is negative in nature, so it is attractive. It draws C closer to the point Q. So this is the direction of EQ. EQ is a vector quantity. Now, we can see here that this angle EP and EQ, as it is an equilateral triangle, so you can see this angle is 60 degree. So this angle 180 degree minus 60 becomes 120 degree. We have to find the net electric field intensity at point C. So this is the net electric field intensity, let's say EC. Okay, this is found by a parallelogram law. We already have discussed many times about the parallelogram law, but before proceeding for it, let's first find in the case what is EP. So formula remains the same, 9 into 10 raised to the power 9 into 10 raised to the power minus 8 upon R square, the distance between C and point B. What is the distance? It is 0.1. So the distance is 0.1 whole square. Okay. Now solve it out. You will get 9 into 10 raised to the power 3 Newton per Coulomb. Similarly, work for EQ. Okay. EQ is 9 into 10 raised to the power 9 into 10 raised to the power minus 8 upon R square. R is same, that is 0.1 whole square. What is your answer? Answer also remains the same because the magnitude in both the values is same. We have to find EC, which is the resultant between EP and EQ, and this EC is found by parallelogram law. So in this condition, let's put the formula for EC, which becomes under root EP square plus EC square plus 2 times of EP EC cos theta. What is theta in this condition? The theta is the angle between EP and EC, which is 120 degree. Put all the values directly, you will get your answer, that is EC 9 into 10 raised to the power 3 Newton per Coulomb. So this is the electric field intensity at point C. Now, there is one last numerical to discuss which comes in your CBSE exams also. So, it is very important one. Just understand it very carefully. Now, let's start with the third numerical. Two small electric dipoles AB and CD, each of dipole moment P, are kept at an angle of 120 degree. What is the resultant dipole moment when it is subjected to electric field intensity directed along x-axis? What will be the magnitude and the direction of the torque? Now, according to this numerical, now let's draw a diagram. Before proceeding further, first, let me make the two axes, the x-axis and the y-axis. So, these are the two axes. We have to mark the dipole in these two axes, okay. So, there are two dipoles, AB and CD. AB and CD are placed in such a way. This is suppose AB, okay. This point is A and this point, let's say B. And similar is the angle, let's say it is CD. AB and CD are at 120 degrees to each other. This is the diagram which is given to you. Okay, you have to find the dipole moment and the torque associated with it. Before proceeding further, if you look at this diagram, that is CD and this is AB. So first, let's check out what are the dipole moment associated with it. That is, if along AB I am talking about, so this says the dipole moment, let's say P1. If I am talking about CD, so the dipole moment is, let's say, P2. So along AB the dipole moment is P1, along CD the dipole moment is P2. Now, you can check here if this is a dipole moment, that is P1, and this is the dipole moment, that is P2, okay. Let me write it again. This is P1 and this is P2. Now, if we have to find the resultant of P1 and P2, so we have to go into the parallelogram law. What is the parallelogram law? It states that the resultant is given by the diagonal of a parallelogram. So, let me first make a diagonal. Okay, suppose this is a diagonal and this becomes the diagonal of a parallelogram which is represented by P. let's say R. PR means the resultant of the dipole moment, that is P1 and P2. So you can write here that PR is the resultant of P1 and P2. Now, use the parallelogram law, the formula, that is the resultant is given by under root P1 square plus P2 square. Okay, this is square 2 times of P1 P2 cos theta. Theta is the angle between P1 and P2, which is 120 degree. Cos 120 degrees minus 1 by 2. If you solve it out, then you will get the answer, that is P1 is equals to P2, which is equals to, let's say, P. Okay, this is given to you that both the dipole are equal. That is P1 is equals to P2, which is also equals to, let's say, a alphabet, that is P. Now, instead of P1, instead of P2, we will put P square, P square. Okay, here also P square. So now, according to this assumption, your answer, that is PR, is coming, that is P. So this is the first answer, that is the dipole moment. What is the resultant dipole moment of these two vectors, that is P1 and P2? It is simple P. Second part, you have to find the torque. What is the formula for torque? The torque has a formula P dot E sine of theta. What is P in this condition now? P is the resultant of P. I am not talking about the P, P1 or P2. We are talking about the resultant P, because the torque is also the resultant force. Okay. So in this condition, it remains P, because we have calculated that resultant P is equals to P. Now, it is E dot sine theta. What is sine theta? Theta is the angle between P and E. So now let's work upon the angle between PR and E. This is PR, this line is PR, and this is electric field. We have already seen the numerical that the electric field is directed along the x-axis. So you have to find this angle, okay. Now, this is 90 degree, okay, the y and the x-axis is 90 degree, and you can see from here that PR is the diagonal of a parallelogram. That means that PR is the bisector of this 120 degree angle. So this angle becomes 60 degree. Now, there is already a much mess, so let me take out the small portion of it, okay. Like for example, this is y-axis, this is x-axis. You can see here, this is PR. You have to find this angle, this is theta. This whole angle is 90 degree, which is given to you. Okay, now this angle, I am talking about this angle. This angle is 60 degree. How 60 degree? Because the resultant at P is the diagonal of a parallelogram. That means it is the bisector of whole 120 degree angle, and the half of 120 degree angle is 60 degree. Now let's subtract 90 degree and 60 degree. You will get theta, which is 30 degree. So the angle between the resultant, that is PR, and electric field intensity is your 30 degree. Now substitute the value here, sine 30 degree. What is sine 30 degree? It is 1 by 2. So torque becomes P into E by 2. So this is the magnitude of a torque. But there is one point also. What is the direction of torque? How the direction is found? The direction is again found by right hand screw rule, and according to it you can use here the first vector in this condition is P. So direct your stretched finger along this P. Okay, now curl the finger in the direction of a smaller angle of the second vector. So this is how the fingers are curled, because this is the smaller angle between P and E. My thumb is pointing into the plane. That is, what is the direction of torque? The direction of torque is perpendicular to the plane, and that too into the plane. Okay, so this is the direction of torque, and it is represented by this cross sign. So this is the magnitude of torque, and this is the direction of torque that we have already calculated.